Hello, I'm Mick Jennings and I'm here today at the Danfoss Clinic just looking at a few features and functions of the new FC range of products. Here in front of you you can see a graphical keypad which is an LCP 102, and the LCP 102 is a keypad that you can use throughout the whole family of FC range of products. In other words, you can use it on a VLT HVAC drive, a VLT Aqua drive and the automation products as well. This particular clip I'm going to be showing you the self-tune, or the AMA as Danfoss like to call it, the automatic motor adaptation. Really it's just a series of tests that we can do on the motor and drive package, and it will work out resistances and reactances of the motor. It will check out the cable into the motor, and it'll also check, all your phases are there and that kind of thing too. So it's a useful thing to do. Now it's not necessary. If you take the drive out of the box, it should work basically with a motor straight away. But it gives you much better performance if you do it. So it's probably well worth doing. And I'm going to just show you how to do it today. Now I know that the parameter that we're looking for is in group 1, and the parameter is 129, automatic motor adaptation. So I'm going to just hit the main menu. When you hit the main menu, look, it takes you back to where you were last time you were looking at in the main menu. So I'm going to take you back to the start where you would like to. So you press the main menu twice and then you go back to the start where it starts with 0, 1, 2, 3, and it shows you the logical groups that Danfoss like to use. Nice concept this, because it means that you can find parameters that you don't know where they are because of what they are. For instance, anything to do with a load and motor would be in group 1. So your currents and that kind of thing, your torque, characteristics and all that kind of stuff is all in group 1. So it's easy to find. Makes it nice and easy. Okay, so we want 1-29, so I want to drop into group 1 and say OK. And now I'm in the group 1, but now I need to look at for the 120s. So that's motor data, look, 1-2 star. So I'll go down to 1-2 star. Now it's 1-29 that I want, so instead of going down through the 120s, I can just go up and I'm in 129. At the moment, this particular parameter is turned off. So if I say OK, you'll see that the cursor drops in under the parameter, and now I can scroll around to the choices in that parameter, and I'm going to choose Enable a Complete AMA. Now if I just press that again, you'll quickly see Enable Reduced AMA. I'll talk to you about that a little bit later on. Anyway, Enable Complete AMA. I'll say OK. Now, before you do this, you must have set the drive up using the quick menu, and there is another clip to show you how to use the quick menu and set your drive up to the basic settings. So you need to put the motor nameplate data into the drive. The other thing just to quickly mention is it wouldn't always say ready there. If you have got one of your terminals set up so that it is a coast inverse, then you'll see this, because you've got your coast off. And all that really means is that terminal 27, in this particular situation, we've set the terminal 27 to be the coast inverse, and so there must be 24 volts on it before you can get a start. If you haven't got 24 volts on it, then it inhibits the start and it will say coast along there. So we've put coast back to where it was now, and it says ready to run, so I'm going to press hand on just like it asks me. Press hand on to start AMA. So I'm going to press hand on, and away we go. Now we're in step 2, step 3. There are 16 steps in all. Let me just tell you a little bit about what's happening while this is going on. First of all, obviously when you take the drive out of the box and you set the drive up so that it's you put the motor nameplate details into the drive, then it goes away and looks at just a lookup chart really, to look at typical values for that motor that you've described in the setup. Now that's all very well and the drive will work fine, but if you do these tests, it means that the actual resistances and things are actually calculated, and you get much better performance. Now it's done two ways. First of all, there's a resistive test, and basically they just use Ohm's law. They'll inject a DC voltage and look at the current, and just using Ohm's law they'll say that V over I is resistance, and they can work out the stator resistance. But there is also, and you'll hear them starting up in a minute, frequency sweeps, which are basically, it's a clever algorithm to measure reactance and gives you impedance and reactance as opposed to just resistive, so it gives you much better performance. That's why the complete AMA is so much better than the reduced AMA. Having said that, the reduced AMA, it's okay, and it's better than not doing one at all. And that one really is just a resistive test, so it just sets the drive up, the current loops up using a resistive test only. Okay, we're on step 12 now, so we've got a little bit more to go. I'm going to tell you a few other things as well. This test is a static test. In other words, a lot of our competitors will do an automatic motor adaptation of sorts. The only thing is that they'll expect to run the motor up to full load. Run up to full speed with no load. In other words, you start to knock couplings off and things like this, or knocking belts off, so you can run the tests. This is a true static test and doesn't move the shaft at all. Anyway, it looks as though we've completed the AMA. It's okay. It says everything's okay to finish. So I'm going to press OK just like it asks me to, and we're back to square one again. Thanks for watching.